Here's Ian. Okay, I think that means we're live. So Ian, do not touch that. Thanks. All right. You can probably not. It's okay. I haven't had a face transplant to a more handsome version of myself. That is our speaker for today, Robert Thibault. Right, I've got that going now. Right, yeah, so welcome everybody, we are live. So this is the RIOT Science Club at Wolverhampton, where I'm being sort of helped and co-producing with Ian Lahart, who's off camera now. And today we are joined by Robert Thibault. And just a quick few announcements before I introduce the main event. So we have a few speakers remaining for this semester, and there's a few updates. So we were supposed to have Professor Edzard Ernst, the bane of Prince Charles and homeopaths the world over. He was supposed to give an in-person talk at the University of Bristol next week, I believe, but or the 1st of December. Unfortunately, due to the strike action, we've elected to postpone his talks, and his talk is now on the 9th of December. And his talk is also in person as well. So if you're in Bristol, or if you want to, pay a visit, go to Bristol and say hi to Hugo and Julio and Robbie, the team at Bristol, and also see Edzard. And then another update is that the talk we have on the 8th is by Bjorn Brems, and he will be talking about academic publishing, and his title has changed, and it's sort of good riddance, publishers are leaving academic publishing. So all the information can be found on our Twitter handle at RIOT Science Club, and our website www.riotscience.co.uk. I think that's it. So let's move on to the main event. So we're joined by Robbie, who I'm very privileged to say we are collaborators, I guess. We collaborated on one paper that he will be talking about. Robbie, his sort of background, his aim is to sort of increase the reliability and efficiency of scientific research. He's also interested in promoting evidence-based decision-making and encouraging the public uptake of science. He completed a PhD in cognitive neuroscience at McGill University in 2019, and then he moved to Bristol, I believe, to do his postdoc. He's also now moving to Stanford, so congratulations again, Robbie, for that. He's also published a book, Casting Light on the Dark Side of Brain Imaging, and that's actually how I found out about Robbie, through fMRI neurofeedback and EEG neurofeedback. And a link to his book is on our website. And in his spare time, he also does rock climbing and other outdoor activities. And today he's going to be talking about registration, its shortcomings, deviations and solutions. So I'll hand the keys over to you, Robbie, and thank you again for giving your time this evening. Take it away.
Great. Thanks for the kind introduction, Sam. I guess the first thing I'll point out, I switched the title just a little bit because sometimes in meta research, I found that we can be very focused on the shortcomings, which is the first thing that came to mind for the title. But I just switched it to triumphs because we've gone a long way with registration. It's worth taking note of the advances that we've made. Then I'm going to talk about discrepancies. And so that is when a registration or pre-registration says something, but then the publication has changed what actually happened in the experiment. And then I'll talk about some solutions that we can use to improve how we do registration. Quick presentation plan. I'll give an overview of registration. I'm going to use the term registration or pre-registration or prospective registration pretty interchangeably. Then the second part, I'll go into a systematic review of that we did to check for discrepancies between registrations and publications. I'll talk about a feasibility study we were running to try to solve this issue of discrepancies. And then the part I'm most excited about to talk about kind of bigger picture solutions that go beyond how we're doing registration currently. My slides are available at that link at the bottom if you want to follow along at your own pace. feel free to open them up there. My background quickly, I used to do brain imaging and neurofeedback research, and this is what got me interested in kind of reproducibility, open science, rigor in research. In the field of neurofeedback, what you do basically is you watch your brain activity in real time, as this kind of flashy picture shows, and you learn to change your brain activity to try to improve attention deficits, depression, kind of any condition you choose. Now in this field, as is true for many fields, there's pretty severe publication bias. Not much research is pre-registered. There's selective reporting, issues in the design of experiments. And so I had kind of written reviews, opinion pieces, commentaries, raising these issues, trying to tell researchers to do more rigorous research. And I had many back and forths with them saying, you're wrong, no, you're wrong, no, you're wrong, until we decided to make an adversarial collaboration and came up with a reporting checklist for the design and reporting of experiments in neurofeedback. Now, this was my first experience where I realized maybe some of the problems in research, it's not due to individual researcher behavior, but it's actually the larger system that we can work together to improve. So it's more of a design problem that if we have the right infrastructure, maybe we can do better research. Okay, so on to the first part, on registration. Quickly, some triumphs about registration. There's over 400,000 registrations that exist, most of these on Clinicaltrialsgov, or many of them on there. Registration, pre-registration has reduced publication bias. It provides an extensive database about information about studies, particularly clinical trials that are being run, and it's improved transparency. Here's two graphs that quickly show how it's reduced publication bias. So on the left, we have a graph of trials funded by the National Heart, Lung, and Blood Institute. In the year 2000, where that vertical line is before that point, none of the trials were prospectively registered. After that point, all of the trials were prospectively registered. And what we see is that null results were much more common after prospective registration became the norm. On the right, in purple, we see a similar finding, but in the field of psychology. Through registered reports, which is a specific implementation of pre-registration, that these registered reports more often publish null findings. Diverse disciplines use registration, so often we hear about clinical trials in psychology, but also systematic reviews, economics, observational research, preclinical research. Many of them are in clinicaltrials.gov. Not all of these are necessarily clinical trials, but it's just a platform that's used. We can see there's over 80,000 registries on OSF registries, and most of the things I talk about today is going to be informed mostly by clinical trials and psychology. These are the fields I'm more familiar with. And to give a quick background in clinical trials, registration is mandatory. Almost all studies are registered. There's policies from the International Committee of Medical Journal Editors, from the FDA, from the National Institutes of Health, it's in the Declaration of Helsinki. Yeah. The purposes of pre-registration can be quite broad and differ slightly depending on the field. So to help recruit participants, reduce duplication, improve reproducibility, transparency, etc. Registration also comes with a bunch of positive externalities or kind of auxiliary benefits, such as helping you plan your study ahead of time or creating a document that you can get feedback on before you actually start your study. But these aren't really the core purposes of pre-registration. These are just additional benefits that come from registration. This preprint by Hardwick and Wegenmakers kind of lays out two main reasons, core purposes of pre-registration that I quite like. So the first one is to reduce bias by ensuring that research decisions are made independently of study outcomes. And the second is to calibrate confidence in research by transparently communicating information about a study's risk of bias. So these kind of hold across the different disciplines that are using registration or pre-registration. All right, on to discrepancies. So what do I mean when I'm saying discrepancy? I just mean researchers said they would do something in their pre-registration and then they did something different in their publication. If this is undisclosed, this can present a substantial issue. So here's a basic one. The registration said enrollment, 1,500 participants. Then the publication says 1,000 participants. Another example, you can look at primary outcome measures. Here it says rate of exasperations, and then when you look at the publication, which is below, it says the primary outcome was time to exasperations. And so discrepancies are just, yeah, here's a few examples of them. Do discrepancies matter? I would argue yes, they do, particularly when they're undisclosed. Undisclosed being the publication doesn't mention that they've changed something from the registration. So they increase the likelihood that results are biased, and when they're undisclosed, they reduce transparency in regards to assessing risk of bias. So let's go through a few examples and see if we think that discrepancies actually matter. So for one example, if several outcomes are registered, but only one is reported. So in my field where I did my PhD in brain imaging, sometimes people do a whole brain image. So they check all the areas of the brain to see if some activity changes between two conditions. Now, if they only reported activity in one area, but they registered that they would do a whole brain analysis, then they're presenting exploratory research as confirmatory research, and this is an issue. Another example is if recruitment stopped at 1/3 of the sample size, this would represent optional stopping, and perhaps it was because the researchers found results that they like, but also perhaps there was adverse events or there was some other reason that it needed to be stopped. One case where I think it actually makes sense to have a discrepancy between a registration and publication is if the surrogate endpoint was put as the primary outcome in the registration, but you also have data on a clinical endpoint. In the publication, what we're actually interested in is the clinical endpoint. And so it makes sense to swap those and then transparently disclose this information. Discrepancies may indicate bias. They don't necessarily indicate bias, and discrepancies should be disclosed, and it's okay when they're disclosed. Now, the consort statement also says that changes in outcomes should be disclosed. We'll get to this a little bit later, but very few outcomes, maybe 10% or less, 10% or less of discrepancies are actually disclosed in practice. Question for you, do you check registrations when you're peer reviewing? I know I didn't used to check them. I used to be happy when something was registered, but I didn't actually open the registration. Now I do regularly. There was this study in 2013 that asked peer reviewers of clinical trials if they check registrations, and they found about 1/3 of them do. Now, we don't know exactly how much information or how thoroughly they check the registration, though. Now, if only 1/3 of peer reviewers are checking registrations, then it's probably pretty unlikely that most readers are checking them. So if a discrepancy is not disclosed, it's not likely to be caught during peer review, and it's not likely to be caught by by readers who aren't going to open the registration. Okay, so that's some background on registration. I presume most of you listening here have a good understanding of pre-registration already, so I won't go into more detail than that. Now I'll get into a systematic review we did where we tried to assess how common discrepancies were. We reviewed 89 articles. 81 of them were based in medicine, mostly clinical trials, and each article assessed several pairs of registrations and publications. So if this was a meta-analysis in kind of normal medicine, our participant is our pair of a registration and a publication. We didn't look at these ourselves. We looked at articles, and each article looked at, somewhere around 100 registrations and publications. We extracted outcomes on outcome discrepancies, non-outcome discrepancies, and some of the characteristics around discrepancies, whether they're associated with statistical significance, industry funding, etc. And we ran some meta-analyses and meta-regressions. What is an outcome discrepancy? This is how they were generally defined. So you can have a primary outcome discrepancy, which is omitting, adding, demoting, or promoting a primary outcome, or changing the timing of a primary outcome. And then secondary outcomes, similar, but just for secondary outcomes. Now, in pre-registration psychology, we're not often as strict with our identifying of something as primary versus secondary, but in clinical trials registrations, it's quite clearly demarcated and tabulated what is a primary outcome and what is a secondary outcome. And then we looked at non-outcome discrepancies too, so things like eligibility criteria, sample size, analyses, etc. Now, not every article we looked at reported all of this, but many of them reported subsets of these outcome and non-outcome discrepancies. Here's a table of our main results. I'm not going to expect you to digest this all in the 1 minute it's on the screen, but I'll just explain it quickly. Here we report our findings, the percentage of studies that had at least one primary or at least one discrepancy of this type, and we report a 95% confidence interval and a 95% prediction interval, which have different interpretations. And then K here is the number of articles we assessed. And again, each article had several, on average, about 80 or 90 registration publication pairs. So if we look at the 95% confidence interval, 29 to 37% of articles we looked at, or of studies, had at least one primary outcome discrepancy, and somewhere between 50 and 75% had at least one secondary outcome discrepancy. So basically a third of papers had a primary outcome discrepancy with a big range around that, and 2/3 had a secondary outcome discrepancy with quite a range around that. If we look at the forest plot, which is obviously way too small for you to read, which is okay, because all I want you to look at is this. The heterogeneity is very large, which just means that the studies, each article we looked at, had very different estimates of the prevalence of discrepancies. The one on the left is for primary outcome discrepancies. The forest plot on the right is for secondary outcome discrepancies. And we tried to run some meta-regressions to explain this, but we did not succeed in identifying the reason for the high heterogeneity. And so what we can take home from here is that primary outcome discrepancies are an issue, secondary outcome discrepancies are an issue, but we don't have a precise estimate of how bad or how often these do occur. For non-outcome discrepancies, there was fewer articles that looked at these, and the range around them is quite large as well. So we don't have precise estimates, but it is clear that there are discrepancies in these non-outcome measures. All right, so those are our kind of main findings around discrepancies, but we got a few additional findings that I can discuss now, which the first one is, are discrepancies disclosed? If they're all disclosed, I'm wasting my time with this research largely because this is a non-issue in my mind. But 22 of the studies, or of the articles that we ran the meta-analyses on, actually also checked whether discrepancies were disclosed, and we find somewhere between 4 to 19% of discrepancies are actually disclosed in the publication, so not that many. Now, the three highest estimates in this forest plot, 2 of them are from systematic reviews and 1 of them is acupuncture, and so they're systematically different than most of the other articles we're looking at here. Some more findings. Industry-funded studies may have fewer primary outcome discrepancies, which may be counterintuitive to some, but to me it actually makes sense because industry-funded studies may just the workflow may be more standardized compared to academic funded trials or trials solely done in academia. Another thing is it's unclear how much the discrepancies are related to statistical significance. So we often hear arguments that, someone switched their outcome and obviously it's because they wanted to report this other statistically significant finding. But when we look at that, that's not actually always the case. Sometimes it is, but not always. And finally, we found 89 articles that document the issue of discrepancies and how severe the issue was or how prevalent it was. But we only found 2 studies that actually tried to do anything about it, that tried to solve the problem. Now, one of them, Goldacre et al. In 2019, what they did is after a paper was published, they sent a letter to the editor. They checked the paper for discrepancies with its registration. They sent a letter to the editor within a few weeks of publication and asked that a correction be made. This study was very insightful and it provided a lot of information, but I don't think this is a realistic implementation to solve the issue of discrepancies because we're not correcting the version of record. We're trying to post-publication peer review where the version of record is published and then we fix it afterwards. I prefer solutions that will fix it before we get to the publication stage. And then there's a second study by Jones now that is currently running, or at least the results haven't been published yet, where they are emailing peer reviewers asking them to consider registration information while they're doing their peer review. Okay, this brings us to the third part of our presentation, where I will explain the results from a recent feasibility study we did on what we call discrepancy review. What is discrepancy review? Basically, we partnered with some journals. When those journals got studies that were pre-registered, they would send them for normal review. They would also send it to us. We would systematically compare the registration to the submitted manuscript, write a peer reviewer report just on this, and then manuscript handling would proceed as usual. So what we're trying to do is correct discrepancies before they're published, so that the published version of record is an accurate depiction of the registration. A quick flowchart of what I just explained is pretty simple. Manuscript handling is pretty normal. We just add one extra review from someone from our team. Okay, so our objectives, it was a feasibility study. We're not actually trying to identify whether discrepancy review reduces discrepancies. We're trying to see if it's feasible to actually implement this workflow to add this discrepancy review to journals' manuscript handling procedures, and we wanted to try to refine it to make it better. We invited 18 journals to participate. 5 of them accepted. 2 of them ended up sending us manuscripts. 2 of them were small journals and didn't get any pre-registered articles during the study period, and 1 of them had difficulty implementing this extra step into their manuscript handling. We reviewed 21 manuscripts. 12 were registered on Clinicaltrialsgov. 7 were on the Open Science Framework. 2 were on Prospero. 12 of these were eventually published, and we had 5 researchers doing the discrepancy reviews. And so we looked at studies not just in psychology, but also in medicine. Now, what does discrepancy review look like in practice? Kind of like a horrible game of spot the difference. You have the registration, you have the publication, and you just try to find all the deviations between the two. Now, we had 2 implementations of discrepancy review. The first one, which we thought would work, didn't work so well, and then we updated it to make it more efficient and more useful for journals. Because what we want is a procedure that journals will actually be willing to and wanting to implement. And so we need it to not take too long and not be too much of a hassle. So the original discrepancy review, we had reviewers would go through the registration and answer questions about these 18 items. So about hypotheses, outcome measures, sample size, randomization, etc. And they'd go through a Qualtrics form that was all systematized just for the registration and do this, repeat the process for the publication, and then check the output of those Qualtrics forms and compare and see where there's discrepancies. Needless to say, this takes quite a bit of time. Once reviewers did this, they would prepare a report, a peer reviewer report, which would look something like this. It would have this table in it, which would report on these 18 items and say whether there was an issue and whether that issue was minor or major. And then we'd have recommendations, a list of recommendations to the authors for how to correct their discrepancies. So for example, something like several non-registered outcomes appear in the manuscript. I recommend the authors explicitly state that these outcomes were not registered, for example, and then list the outcomes. What we're doing here is we're not saying the researchers did anything wrong. We're not blaming them. We're not telling the editors to not publish the work. All we're trying to do is make sure the published version of record accurately maps onto the registration and that any discrepancies are disclosed. So the original discrepancy review method, where we had people go through a Qualtrics form for the registration and a Qualtrics form for the publication and then match them on these 18 items, it takes too long. It's just not realistic to implement as a standard practice at a journal. It felt a little pedantic. We had low inter-rater reliability in terms of whether reviewers thought a discrepancy was minor or major. And there's a few other issues, like the registrations that we were reviewing are just generally not comprehensive or precise enough for this process. The registrations don't always map onto the manuscripts precisely in terms of, hypothesis 1, hypothesis 1, hypothesis 2, hypothesis 2. And so it's hard to actually go to the granularity of these 18 items and see whether each one matches. And finally, we found that the original implementation was not a good intervention, and it was also not a very clear way to assess the outcomes. And it's important to divide these things. So one, we're trying to come up with an intervention that doesn't need to be perfect, but ideally will just change how people are reporting so that they disclose discrepancies, versus running a study to see if this discrepancy actually has an impact where we assess outcomes, which would need to be more thorough. So we updated how we were doing discrepancy review, and we just made it much more freehand. Just had 8 guiding questions that reviewers didn't actually have to answer each one by one, but they would read the registration, read the submitted manuscript, and then just kind of write out what the differences are that they think are important to address. This took much less time, and the discrepancy reviewers preferred using this. So the 8 questions were, the first 3 were just about the registration and submitted manuscript in general. So the first issue here, which we didn't foresee ahead of time, is there's a lot of publications that reference clinical trial registration, but that manuscript is not actually the main report of the clinical trial. It's a secondary report or an exploration, and the main report is published somewhere else. But often the manuscript doesn't clearly identify that, which would be important. 2, whether the study was properly registered, so permanent. 3, whether it was retrospective or prospective. And we had 2 main questions on discrepancies, so the number, content, or prioritization of hypotheses and outcome measures. And then we also just asked, don't go into a lot of detail on these, but while you're reviewing the manuscript, if you notice anything about the independent variables, the analyses, or any notable additional discrepancies, just note these down and include them in your report. All right, let's move on to the outcomes, what we found. So the time for updated discrepancy review took between 10 and 92 minutes, averaging around 30 to 40 minutes. So potentially something that journals could implement as a more regular process. A few other issues that we didn't think we would come by as much, but 4 of the 7 OSF pre-registrations were not permanent. They were just on OSF Home, that webpage, but not on OSF registries. And then 2 additional ones, the manuscript pointed to the link on OSF Home rather than the OSF registries, which is the permanent version. So that would be something that could be included as an outcome if we were to run a trial. 5 of the 12 manuscripts on Clinicaltrialsgov weren't actually the main report of a trial. So again, something to consider if we're going to run a trial to see if discrepancy review works. And none of the manuscripts actually met the criteria for a pre-registered badge. Outcomes. Primary outcome discrepancies, particularly in OSF registries, are very hard to detect because often you have these blocks of text and no clear explanation of this is our primary outcome. And so it actually became quite difficult to use primary or secondary outcome discrepancies as a measure of seeing if discrepancy review would work on OSF registrations. So what we did is we had reviewers subjectively assess how important they thought it was to address the discrepancies. Unfortunately, this had quite low inter-rater reliability. We just had 3 categories. This manuscript has discrepancies and it's not really an issue, or there's no discrepancies. Second category was there's some discrepancies and it's kind of an issue, somewhat important to address. And then the third one was it's quite important to address. But even then, reviewers had different ideas of what was important to address and what wasn't important to address. We got some feedback from from authors and editors, and there was nothing that we got back that said, this process is terrible, I hate it, I don't want to be part of it. And so there was no clear evidence that this wouldn't work, that a trial on discrepancy review wouldn't work. Another finding was that submitted manuscripts hardly ever disclose discrepancies. So again, discrepancies are an issue because they're almost never disclosed. And authors did address most of the comments that discrepancy reviewers provided. So this extra peer review step is making some sort of difference. Should we run a trial? Perhaps. If we do, clinical trials and OSF registrations, we'll have to do those differently. Journal recruitment might be a limiting factor. And the effect size that we're looking for really depends on what journals are willing to pay for this kind of service, because we can't expect to ask peer reviewers to email a random peer reviewer and say, hey, would you like to do discrepancy review? The process is not the most exhilarating, let's say. All right, On to the last part, beyond conventional registration. And here is just kind of my thinking evolved during those two studies I just spoke about, and moved towards kind of ways that we can improve registration beyond the ways we're typically thinking about it. Before I get into these potential solutions, I'll just talk about some of the shortcomings really quickly, just summarize them. So comprehensiveness is an issue. For example, this is an outcome on the first Clinicaltrial.gov registration. When I opened it up and I looked for a study or a registration, I found this. We don't know what the researcher's hypothesis is. We don't know what their analysis is. We don't know what their operationalization of this outcome is. And so there's some information that's missing. There's issues around precision. So on OSF registrations, again, I just opened up OSF registries, came across one of the first registrations I found, and this is a block of text for a hypothesis. I'm not going to read through this all, but there's many hypotheses in here, and they're not all exactly clear. And then it would be difficult to map these hypotheses onto what is actually written in a publication. There's the issue that much of the registrations, or some registrations, are talking about exploratory work, but they don't clearly label their study as exploratory. Another issue is the timing of unblinding is unclear. And so if researchers run a study, they don't look at the data, but they finish running their study, and then they register their analysis plan, and then they look at the data, that would be okay. But we don't know when researchers are unblinding the data and actually looking at it. Now, even in Clinicaltrials.gov, there's this beautiful history of changes function that I love, and you can see what's been added and modified in the registry, but there's no information about the timing of unblinding, which is a very important factor in deciding whether the analysis was made based on outcomes that the researchers saw before doing their analysis. Some researchers, particularly in clinical trials, some think or treat registration as a box ticking exercise because they have their protocol, which is much more thorough, but isn't always shared. And they sometimes report, for example, in our trial, there's one study that reported, oh, we just did the registration quickly and didn't register the right things from our protocol. We fixed it now and updated the registration. They didn't seem to care. And finally, the version of record is unclear. We have ethics applications, funding applications, publications, protocols, registrations, and each of these describe the same study and might report different things. In fact, there's studies that compare all of these different documents and show that they often don't line up perfectly. And so we don't know what the true plan was when there's multiple versions. Okay, so I think the best solutions to improve how we're doing research, to make it more rigorous, more reproducible, will not only make research better, but will also make research easier. So we'll make researchers want to use these solutions. And one of the things that I'm thinking about these days is trying to front load good research practice. So if we look at a kind of diagram of the research workflow, you come up with an idea, you do a bunch of stuff, you eventually publish it, and then there's a post-publication period. Some of our interventions in meta-research or efforts are focused on the post-publication stage. So we're tracking compliance with certain guidelines and reporting that. We are sending letters to the editor, for example, in the Goldacre et al. Study, the Compare Trials project. Some of the efforts are before publication, such as interventions in peer review, including what I've presented on here, discrepancy review, reporting checklists, which have done wonders for the quality of reporting, but don't have as much impact as we'd like on the design of experiments in the early stages, and journal policies, for example. So these come in after research has been done. What would be nice is to put our efforts into improving research at the very early stages. And I'll talk about some of these concepts here. So experimental design assistance, registered reports, registrations based on simulated data, and blind data access policies. And here I'll just bring up this concept that Russ Poldrack brought up in a previous RIOTS talk, which I'm taking this example straight from him. We can think of some of the issues in research as a design problem. This is an industrial paper cutter where you throw the paper in it, and then you press 2 green buttons, one with each hand. And basically this machine is designed so that you can't really mess up. If it only had 1 green button, people might hold the stack of paper, put it in, get their hand caught in there. Now, if there's only 1 green button, we could have instructions for how to use it properly. We could track compliance. We could have training sessions, but you don't need any of that. All you need is a 2nd green button. And so in research, if we think about it this way, if we just make the default workflow easy, then and to guide people through doing good research practice, then we might get at more rigorous and reproducible research in the end. So one way to do this, potentially, is a blind data access policy. And this would be good for kind of observational work where data sets already exist, epidemiology, cohort data sets, and I'll explain what I mean here. So in the blue at the top is kind of your standard workflow when data already exists. You request data, a data management organization gives you the data set, you run your analysis, you publish your paper. Again, simplified, but that's all right. On the green on the bottom would be a blind data access policy, which I've called it. So you request the data, and then the data management organization gives you a blinded data set. So either they give you synthetic data or they add noise to the data. They do something so you're not looking at the true data so that your analysis won't be biased. You prepare your analysis script, your code, based on this blinded data, and then you register that so it's in a publicly available spot. And once you've registered that, then the data management organization gives you the full data set, you run your analysis and publish that. And so in this case, your registration would be comprehensive and precise because you've actually written the analysis script. And also you don't need to take the time to write down everything you are going to do in kind of a block of text. You can just write the analysis of exactly what you're going to do and then just run that analysis. And I guess this figure is a kind of trial we could run to see if this actually has an impact, and at the end to compare differences in the reported effect size or other measures of the output from these two workflows. So one organization has already kind of done something similar to this, Open Safely, which comes from Ben Goldacre's data lab at Oxford. They have a database with information on millions of patients in the UK, but that data is secure. There's a synthetic data set, so not the true data, the data is being changed around, but there's a synthetic data set that can be shared and that people can see to get a sense of the variables and some of the shape of the data. They can prepare their analysis based on that. Then instead of getting the full data set, they actually just submit their analysis online, and then it gets run remotely, and this is documented. And so this again is another way to kind of register precisely and comprehensively, and hopefully reduce the workload of researchers. It's also possible with the holdout sample. So if you run your own study and you just look at half of the data, prepare your analysis on half of the data, then register your analysis, and then run your registered analysis on the other half of the data, this would work. And one thing that I wish I saw more would be doing this type of thing on simulated data. So if we're running a confirmatory study or experiment, we should have a decent idea of what the data might look like. If we have a decent idea of what the data might look like, we can simulate it. And so instead of registering in a block of text what you're going to do, you could just simulate the data or write the script to analyze the simulated data and then register that. Again, if we look at some of the shortcomings of registration, this kind of blind data access policy, simulated data registrations address many of these issues. All right, another concept is experimental design assistance. Now, this has been used in preclinical research by the National Center for the Replacement, Refinement, and Reduction of Animals in Research, the NC3Rs. They created this tool that basically provides a graphic interface where you design your experiment. And this prompts you for additional information, helps you make your analysis, helps you make a randomization sequence. It does all these steps through automated feedback. So you're basically getting automated but systematic peer review before you even start your study. It looks something like this, the graphical interface. And so you have these nodes where you write out your experiment, your units of analysis, how you're going to analyze them, etc. And each node, you can click on it and it'll prompt you for additional information. And when you think you're ready, you click a button, and then it prompts you for all the information that you've invariably missed. Well, I say invariably because when I did it, I invariably missed something. Now, the NC3Rs, when they, in their calls for funding, they request that applicants include an experimental design assistant graph like this in their funding application. These graphs could also be incorporated into a registration rather than kind of the typical registrations we see now, which are blocks of text or tabulated information. One last potential solution or advancement would be registered reports funding partnerships. I'm going to assume many of you are familiar with registered reports. One step further is where journals have partnered with funders, and they, when you prepare your stage 1 registered report, the journals and the funders assess it. So you don't need to prepare one application for the funder, one thing for the journal. And in the end, what you have is, instead of having your protocol or your registration, your funding application, and your publication, all this gets merged into one document, basically. And there's some colleagues of mine at Bristol who've been working on this and seeing if it's feasible to run a study to understand how registered report funding partnerships work. So again, the best solutions, I think, are going to make research better, and they're going to make research easier. Now, I really want to emphasize the make research easier part, because some of the solutions that we're trying to come up with to improve research can take a long time to evidence. So if we look at the registered reports funding partnerships, a recent feasibility study my colleagues ran shows that it could take many years to actually provide evidence that this process makes research better. Now, in the absence of that evidence, if we find that researchers enjoy this process, that it makes their life easier, and we have every reason to believe that it would improve the quality of research, then we might as well implement it as we're collecting that evidence. Quick summary. Discrepancies are common. Policing them might work, but better yet, why don't we just work with researchers to try to front load the best research practices we can and work together. Thank you to all the collaborators that helped on these projects and the funder, and thank you for your attention.
Brilliant. Well, thank you so much, Robbie. That was a fantastic talk and a really nice, well-paced one as well. There's a lot of stuff to digest in that presentation. So just to a shout out to everybody, those in the audience, if you want to ask a question, please do so using the sort of question and answer feature towards the right-hand side of your screen, I think it is. So if you do have anything, just let us know. Oh, in fact, we've got one from a Mr. Pedder, I think, a Hugo, as beaming in from Bristol, I assume. What I'll do, Robbie, is I'll just read it aloud to you, and then you can answer, but you can also probably be able to see it as well, but I'll read it aloud for the purposes of those watching.
Should I stop sharing my screen here?
No, you can leave it on, or yeah, you can, whatever you like, it's up to you. I think just leave it on for now, probably best. Yeah. So Hugo says, what about making the discrepancy review even less formal? It could be kept as part of the standard peer review process, but reviewers could just be reminded, e.g. as a checkbox via the peer review submission system, to check the study against the registration.
Yeah, so it's definitely an option, and that's kind of what one of the ongoing trials is testing out. They're just emailing peer reviewers with the registration information, the primary outcome, and saying, you know, check the registration. I don't feel that this will be sufficient to have a substantial impact, but again, that's kind of an empirical question that hopefully once the other results are published, we'll have an idea of that. But yeah, that's also an option that would be worth testing. Yeah, because all these issues, it's cost benefit. So it's if it takes very little effort, but it has some benefit, versus if it takes a lot of effort, but it has more benefit. Either one is worth testing.
Mm-hmm. I guess sort of related to that, I have a question. Is you say in your review that I helped out with at the beginning of the talk about when you sort of did a review of reviews, looking at discrepancies, that there was a lot of heterogeneity, and I'm guessing some of this is just heterogeneity in sort of how they identified discrepancies and the sort of protocols that they used, even though they were sort of looking for the same thing. And I wondered, wouldn't it be good? I guess my question is, wouldn't it be good if there was kind of like a practical guide that could standardize exactly how people do this, unless there is already one in existence?
There's a standard for identifying primary outcome discrepancies, which is adding primary, omitting a primary, switching a secondary to primary, switching a primary to secondary, or changing the time of a primary outcome. And I think this was established, kind of the first people that ran this type of work in 2004 used this method. And then some of the papers that we reviewed in our systematic review said specifically that they used this way of just detecting a primary outcome discrepancy. As for the definitions, particularly for non-outcome discrepancies, they varied quite widely. And so some, I'm trying to think of an example here, but yeah, some for sample size, for example, some said if there's a 20% discrepancy in sample size, we coded it as a difference. But if there was less than 20%, we didn't code it as a difference. And so there's no standard for that type of change. And many of the papers we looked at also didn't clearly say what they considered a primary outcome discrepancy, for example. So we're not sure if they considered, switching an outcome from, instead of checking it at 10 weeks, checking it at 20 weeks, if they called that a discrepancy or not. So there's some variance within the studies in that regard. Each study also sampled different articles. So some of them were, say, the top 5 journals in surgery, and then looked at trials from there, whereas other ones were analyzed clinical trials broadly. Yeah, exactly. And if I remember, there was sort of ambiguities over what sort of version of the protocol that they used. So of course, with clinical trials, you can update your version, and quite rightly so, you can do that. But do you compare the first version that was given, or the one that was most fleshed out, or it was the one just before they enrolled participants, say, for example? Yeah, so I think over half of them didn't tell us which. Yeah, I don't remember the exact figures, but I think about half of them didn't tell us which version they looked at. And then some checked the original version, some checked the most recent version. But when we ran a meta regression on this, it wasn't clear that registrations that were updated, or when you check the most recent version, that it was actually more likely to match the publication. But a quick note on the heterogeneity. It really matters what level we want to do interventions at. So if we're talking about making a change to Clinicaltrials.gov, then the heterogeneity is not as big an issue, because we would be making an intervention that targets all clinical trials. Whereas if a specific journal is trying to implement an intervention, say, again, like a journal in surgery, then they would want to know how bad the issue is within their specific discipline. And so, yeah, the heterogeneity can matter, but it can also be less of an issue, depending on the level of the intervention we're thinking of. So a practical guide, I guess, just going back to my original question, it would only sort of work at the level of, a particular area, say, because they will have their own sort of issues with how studies, keep their records up to date and what stuff is missing or ambiguous. Is that sort of what the point you're making there? Yeah, can you repeat that? I'm not sure I got it. So my original question was because I was just trying to think, another way to approach this would be by having a practical guide that people could follow of how to do a discrepancy review. So and then that would help sort of have a standard across the field, regardless of field, across disciplines, and that will allow them to sort of reduce some of this heterogeneity and allow less noise, so we can sort of quickly identify what are the key areas that are going wrong here that could lead to better practice. Yeah, I guess more efforts could be put into understanding the heterogeneity, or running the next study just randomly sampling from the entire medical literature, for example, and then you get an overall picture. But in my mind, I'm very focused on kind of practical how to address these issues, and I think from what I see, we have enough evidence to try to that it's worth trying to address this issue and starting to run interventions and tweak the system to address the issue.
Interesting. So we have another question. So do you think it's feasible to automate the process of checking registration, publication discrepancies? So for example, using natural language processing?
Potentially for primary and secondary outcomes in studies and experiments registered on Clinicaltrialsgov or other clinical trial registries where primary outcome, secondary outcome is clearly demarcated. In terms of psychology, registrations in psychology or economics or other fields, I think this would be very, very difficult to do.
There's I have a question. So my partner, she works at Great Ormond Street Hospital, and she's sort of a research administrator, and she sort of deals with the kind of administrative burden that clinical trials impose on people. So she's tells me all kinds of stories about what I didn't know about how difficult it is to register a trial and things like this. And one thing that's interesting is that, again, just going back to clinicaltrials.gov, is they do kind of do a screening of trials that are registered on clinical trials. So if you have an outcome measure that's, say, ambiguous to the lay person, that is flagged up, and then it's sent back to those that want to register a trial. And so I guess I'm going back to what I wanted to before, because I think maybe your proposed solutions are good, but they're quite a significant sort of overhaul, and you need to get buy-in from quite a lot of people in order to sort of enact them. Would you agree or not?
Yeah, and depending on the solution. So for the example of the blind data access policy, all you need is a data management organization to update their policy. And then everybody who wants to access that data set will then go through this workflow. And so you don't need buy-in from multiple different people. You just need one organization for that. In terms of the experimental design assistant, if you have one funding agency, they have the power to say, we want you to apply for our funding with this design assistant. And so to make an overhaul to a massive system like clinicaltrials.gov would obviously take a lot of work. But in the meantime, we can make these, substantial steps if you, but not complete overhauls.
Right, yeah. So just to put in context why I mentioned that sort of a bit at the beginning about because I think the reason why, I forgot who was talking to this about, but it seemed that there was when it was made sort of mandatory across disciplines to sort of register your outcomes at least. I feel as though they just selected what would be the most effective minimal thing that you can do. And now I wonder whether there's like a middle way that would still move the dial but wouldn't require like a significant sort of support or enthusiasm to take it on. So the reason why I brought up this thing about having somebody screen clinicaltrials.gov for ambiguous outcomes, the reason why it's a layperson is because they don't have experts to sort of screen them. So I just wondered whether there'd be an even easier approach where you could even have like an element of peer review at the registration stage, where you could invite experts to sort of highlight issues with ambiguous outcome measures and things like this to a more granular level than an expert can do. Obviously that again presents practical issues, but I just wondered whether there's even just a tweak of what we do already could lead to greater gains without the same amount of input. Sorry, that was a really long-winded question.
Oh, that's all right. Yeah, I think I was proposing kind of these larger unconventional solutions, I guess, but I think just tweaks to the system could work as well. So for example, right now when you register your primary outcome, you must put the time frame that you measure. And so people put the time frame because you have to, but you don't have to put, for example, the units of analysis. And so when you put an outcome there, it can be a broad outcome, but you don't actually have to put necessarily the exact scale or how you're going to analyze the scale. Mm-hmm. And yeah, you can, it's kind of like so you could have text boxes for input when you're doing your clinical trial registration or registry of another version where you just have to, you're forced to input more information. And the idea there again is just make it kind of the default automatic workflow. So instead of having some instruction document on how someone should register their outcome, just when they go to register, just prompt them. Yeah, and until they put in something reasonable, it doesn't get registered.
Yeah, but exactly. Again,
yeah.
No, that's exactly what I was sort of moving towards. So very quickly, with ADHD, there's loads. I'm sort of doing a similar discrepancy review in ADHD trials, and there is an issue that you have so many out rating scales, but there's so many subscales that you can pick from. So you can actually get away with just saying, okay, we're going to do, ADHD rating scale, but there's like 3 possible subscales that you can include. So if you force on people, okay, you need to register exactly what subscale you have, then that will, the trickle down would then be their analysis plan would be kind of more clear by comparison, and it will tether them to a sort of a hypothesis that they should test in a way. So that by just asking for that extra bit of information, it could, sort of force multiplier, if you like.
Yes, there's a paper that came out in 2017 by Zar and al. That looked at clinical trial registrations and how detailed the outcomes were, and they kind of talked about 4 levels of detail in an outcome. So the overarching, attention deficit, and then the second level was the specific scale, and then I can't remember exactly what the 3rd and 4th level was, but then it got to the point where you say the unit that you're going to analyze and whether it's going to be dichotomous, continuous, and so you're actually getting information about the analysis there without actually asking for the analysis plan.
Interesting.
And I think they found that, I'm not going to give the percentage because I can't remember exactly, but they did find that some, but not that it wasn't super common to actually keep to get down to the level of granularity that would be ideal.
I might ask you for that paper. Thank you, Robbie, for indulging me in that sort of very niche question I have about my own work, really. But Ian has got a question. Do you want to ask it, Ian?
It's just following on the back of that answer, really, Robbie. So how do we improve the quality of reporting within these clinical trial registries? So we know that there's already the WHO minimum data set that tells the author what to report in terms of what detail, but it's really poorly adhered to. So how do we actually improve adherence to these kind of guidelines?
Are you talking about the reporting in the registration or the reporting in a publication?
Well, first of all, I'm talking about the registries, because that's where you start from, and a lot of these discrepancy ones, that's where the issue lies. When you look at the clinical trial registries, they're really poorly reported in the first place.
Yeah, so I don't have a clear answer to your question, unfortunately, but I have some thoughts. So researchers are often asked to do everything themselves, so including registering their research. I know in the UK there's a new policy that where information is going to be extracted from protocols to ethics applications and then registries made from that. I don't know all the details on that, but the concept of offloading the registration away from researchers who may treat it like a box ticking exercise and onto somebody else who has more time and has access to a full trial protocol that can extract more thorough information and knows the benefits of doing it well, might make it kind of, having fewer people do it, but do it well, and offloading that work away from researchers could be one way at least to improve that.
Yeah, great, because I often think for especially for clinical work that's funded, you're offered the clinical trial units offer assistance in terms of in the design of the experiments. There's something in the UK called a research design service, but for some reason it doesn't appear to help. I'm not sure how involved they are when it comes to registering the trial and on these registries, but it just doesn't seem to that they do much of that work, you know. And I think that work is done somewhere, because the detail that you have to provide for something like NHS ethics, you know, is massive, you know. But you know, so that detail is somewhere. But just, I think you mentioned it in your talk, just when it comes to the registries, it's just a, you know, an afterthought. Oh, let's just stick something on the registry. You know?
Yeah, and it'd be nice if all those protocols were shared, but of course there's issues around confidentiality. So somebody needs to kind of go through the protocol and change it so it's appropriate to share. But again, we can't ask researchers to do everything. And it's kind of a larger thought I have in the research ecosystem, where we need funding for people like data managers, for people to help with registrations, for statisticians. But we're still working off this somewhat outdated model where there's a researcher who knows how to do everything and is responsible for doing everything, as well as teaching and service to the university. But often in certain funding applications, there's not space to cost these people who could be very useful.
Cool. Okay, well, I think we may have exhausted all of these questions. I'm just having a quick scan. I don't see any more. Ian, do you? I don't have any other questions to ask.
Nope.
I think it's absolutely brilliant work, and it is how to describe it, eye-bleedingly difficult to do what you've done, Robbie, to sort of ruin your eyes to try and check these discrepancies. It is incredibly difficult, and it's definitely something that I don't want to rush back into doing quite so soon. So I can see that it's really quite impressive what you're doing, and the fact that you're trying to improve best practice as well is really quite something. So thank you so much for your time, and carry on with the great work you're doing. Good luck with Stanford, and I'm pretty sure you will get another invite in maybe a year's time, so you can give us an update on how well or how horribly things have gone with these projects. It could go either way. So thank you again. Ian, I guess you can say a few last words, or just finish the stream. Okay then. Thank you. See you later, everybody. See you all next week. Bye.